is probably, so I just got the message of the recording. Zaha did is like, it doesn't really need a introduction. You know, it's one of the leading design practice, you know, around the world, delivering iconic projects all across the globe, sort of 400 plus staff. And the Zaha VR group that sits within the architectural practice specialize into integrating the emerging technologies into the architectural and design workflows. Next slide. AKT-II, structural engineering, design-led, based in London, but working all across the world, collaborating with different architectural practices, and leading into the sort of complex design and, you know, materiality and applied research. You know, within AKT, there's a part which is kind of looking at applying research, looking at on the side of material application, but also on digital workflows and development, let's say. And then next slide, please. And then Sweco, obviously sustainable consultants, MEP, design engineers, innovating across 70 countries around the world, and also specializing in digital simulations and digital design, obviously seen as sustainable leaders for everything that is about obviously MEP and sustainable design. Next slide. So just a little bit of an overview of what the 2-year research sort of tried to condense, which for this space, 2 years seems like a long time, but actually we learned on our skin that it's actually not that much in a sense. So we looked at, the project was very ambitious, obviously blending the different typologies of work for 3 different practices, which are looking at the same project but under different lenses, is obviously a very big task. So we split it down, you know, into forensics, so understanding and establishing the current status on how AEC operates, and the limitation of the current workflows, the current software interaction, the current design interactions. Obviously, then looking at requirements for a congregated multidisciplinary design and simulation, trying to understand for each and every perspective a common definition of how we iterate during design. So almost creating what is the PrismArch, the platform DNA, what was the minimum requirements. So we looked at tagging and sphering of data, which my colleagues will explain a little bit more in detail. Looking at data security, because obviously, you know, sharing data within larger organization or across boundaries, client side, will have, you know, a very big impact in managing it into a secure environment as well. Information management, how to access information quickly and cross-pollinate between different practices has been you know, a fundamental part of the equation. So looking at query systems that are being integrated and you know, seamlessly working. And then obviously a definition of a holistic user-centered requirements that allow the user to be able to navigate into this larger taxonomy and ecosystem. So then we also looked at the definition of the UI, so different operational scenarios, trying to envisage and understand how people would interact within the platform and what would be required for people to have to be able to achieve those interactions. And then obviously proposals for the VR user interface, so a classification and a layout of a wider UI. So we're looking at primary gesture-based interactions, how will people kind of interact within their own sphere, but also within interacting within other participants in the platform. Tool-based UI, so accessing tools, you know, in a seamless way. User experience sequence and environmental UI, obviously, they were part of the study, and we're going to go a little bit more in depth during this talk. And lastly, obviously, we did several mock-ups in understanding and achieving the user interface freedom that we required. Next slide, please. So just a bit of an introduction. Obviously, I hope that people joining the talk have got a little bit of an understanding of how we work in terms of the AEC, because obviously this should be related to your interest. But obviously the challenge is in kind of like driving throughout a project and having to dissect a different aspect from the different perspective, which could be from a client side, from a project manager side, from a quantity surveyor, an engineer, an architect, you know, a lighting consultant, and throughout the different stages of the design, from the concept to the post-construction, is not a linear process. It's a process that actually spans across and iterates across the different disciplines. And, you know, obviously, we looked at how we currently work and what was the required redefinition of a workflow to allow these iterations to happen a lot more coherently, but also more efficiently in one single platform. So we started with that to really from the basics and really trying to redefine the way in which we work and which we interact together. Next, please. So the first step to do that exercise was obviously to understand how the current industry works. And we obviously have a good perspective from our disciplines. We interfaced and worked with Zaha. Zaha worked with AKT. AKT worked with Reco. So it was a very good mix of experiences, and we had real projects that we could leverage on to understand how the interaction would happen. But we wanted to also open it up and kind of looking at how immersive reality sort of was used in the AEC currently, and how where was the gap and where was the limit. So we did an exercise of you know, evaluating and looking at the information currently, and we started to look at immersive reality as a way of evaluating simulation in real time, not excluding everything else that is happening in that space, such as, you know, emails, phone calls, notes, you know, so trying to blend all the different streams of information into one unique place. Next slide, please. So we also did an extensive sort of review of existing software, and we tried to break it down and understanding each and every package strengths and weaknesses, you know, against immersiveness, really to kind of trying to leverage out and pick up the best out of each and every pre-existing solution, and trying to also understand the pitfalls that every solution would have, to trying to avoid replicating that into the platform. Next slide, please. This comprehensive study that actually took pretty much, you know, good part of the first 4 or 5 months of the research, gave us a very good picture. You know, I don't know if you can read on this slide, but basically on the y-axis we have pretty much every single software that has been used during the project, from the software they used to take notes to the delivery package that allows, you know, contractors to pick up the beam model and deliver it on site. And we split it per discipline, so architecture, structure, and MEP, and we split it also for on the x-axis we have obviously the project stages, and we try to give it a go to really understand where the immersiveness sits. And where, you know, so from the top to the bottom, we can see fully immersive software, you know, good specialist sort of analysis software, 3D software, 2D software, and then communication and physical software. So really, this is kind of the initial map that we use to kind of then understand and pick and choose the items that we wanted to transfer on the platform. I will pass the baton to Zaha VR, which is going to go through a little bit of the initial visioning and how we developed the whole platform now.
Thank you, Edo. Yes, as you can see, the discontinuous software landscape had a lot to be desired. So that brought us into what we might envision the PrismArch functionality to require. Firstly, we wanted to differentiate 4 core classes inside immersive reality. You have the immersed human being. Everything that is imported into this space is called a design object. You need the UI in order to be able to interact with the design object, metadata, and also to set the settings required by the immersed human. And the metadata is all the secondary information that is required for anything from BIM, excuse me, to other intelligent data management systems. And bringing those core classes into an immersive space with a certain amount of realism. You can see that the model, the metadata is the set of spheres, which we call the metagraph, with links to what is being called out on the 2D visualization boards and the design objects and assets, in this case, both 3D and 2D inside the immersive space. So each one of these classes needs its own distinction, and we also need to understand the interrelationships between them all. And this is just to highlight how the immersive reality requires us to consider every aspect of everything that we bring into the virtual space. We see PrismArch as a single system of nested relationships, going from the individual users to the multiple disciplinary teams, to the cohesive PrismArch space and data for a given project. Then also thinking more ambitiously, you can imagine these projects feeding into world data and eventually the public domain emerging as a new collective virtual domain. So now when we understand that we all have to be in the same space with all of the project data, we also need to define the legal boundaries. So the individual who is on board and needs to go through a legal protocol to make sure that it is their identity and nobody else that is acting or participating in this space on their behalf. So everything from the age check, avatar creation, and we would imagine that somewhere down the line, you'd also have the online banking systems as well for the payments and transactions between clients, companies and their employers also to happen in this immersive space. And when a user joins, they will link up with the company, with a mother company, which is going to provide their corporate credentials and IP link, the corporate UI extents, and access to any software and licensing. The company itself will need to be onboarded. So we're also looking at the individual, the company, and the links between every one of these levels. On the individual level, it's, excuse me, so not only does every level from the individual to the public and collective need to be defined, but also the connection or the synapses between any two levels. They need to be given that particular definition depending on what are the two entities that are interacting, what is their legal relationship and their status. So going from the individual through the professional, disciplinary, collective, to the multidisciplinary, to the interactions with the client and other team members, to the public. Each one of these is separately defined, as well as their interactions. So together with the nested organizational structure, we need to be able to generate ad hoc groupings. On the left, you see the users working inside their respective teams inside the PrismArch space. On the right, you see a meeting that's generated between individuals from several companies where we need to exchange information. So that type of flexible grouping is something that we also have to keep in mind. One of the things that had been motivating our research is the golden thread requirement, which is part of the Building Safety Act. And it was only brought into force last year, but had been in discussion since 2019. It stemmed out of an independent review of building regulations by Dame Judith Hackett after the Grenfell Tower disaster of 2017. And it pointed to unclear roles and responsibilities, and therefore a lack of accountability for safety of the building throughout its life cycle. And the legislation aims to have a record of key decisions, as well as the reasons for them, from the inception of the project through the construction, as well as any further renovations undertaken during occupancy. And we feel that this accountability and record keeping is a key asset of the PrismArch system. In order to make this possible on the granular atomic scale, all elements in PrismArch, they require traceability. We need to know who authored it, when, and using what software. And this is something that we'll need to apply to every element at the object level. In the process of design and communication, these discrete elements are taken together or sphered and given a layer or meaning on the semantic level through tags, such as, say, living room or chairs or upholstery. So conceptually, we're moving away from BIM and COBie formats to a more flexible data system of assigning meaning to interdisciplinary data. Because as we have found, no one system or no one software solves that problem for us. We need to be able to assign semantically meaning to the data as it emerges. Therefore, we have a system of tags which inherit the original metadata from outside software. There's also automated tags based on the topology, any user-added tags, such as a date for a meeting, and anything that comes from the existing associations between objects within the PrismArch database. Ideally, we would have this be automated by AI. So tags are a key and value, a type of qualifier, and they're added to the semantic groupings or to the groupings called spheres, which can apply around a single object or around a group of objects. They'll also be recorded in the project memory, and only the original owner of the tag or authorized person can modify it because it forms a part of the project record. So with the data de-siloed and consolidated into a unified data space, we looked into moving beyond the visual programming style data representations to multidimensional data structures, such as the force-directed graph, that could be more fitting for immersive interaction. Metadata and how we want to handle it immersively in close-knit relationship with the other classes, that sits at the very heart of the PrismArch user experience requirements. And this is something that we'll talk about in more detail, and I shall pass the baton over to Ola to discuss this further.
Yeah, so in order to move on into this, to define this kind of experiential ideas to develop the platforms, the interfaces, and establish those interactions, we went back into a kind of forensic and look really into detail. How do we interact? What is the kind of professional workflow, and then how we interact at the team level and the multidisciplinary environment, and also including a kind of presentations and how we communicate design to the external parties. If we move on to the next step. So just looking at our very research at the beginning into a key case study projects, we've identified a kind of set of rituals that are discipline agnostic, that we all perform in our daily workflow and workday. So starting from initiating a project being a kind of specific special event where we incept the project and need to load in externally created content onto the platform in order to begin the work, through creating a content in PrismArch, as well as meeting, and how do we organize the meetings, also defining a kind of types of meetings that we have, which could be in-discipline meetings that are design reviews, interdisciplinary meetings where we share assets with other disciplines in order to get everyone's input, as well as client meetings and the presentation. And in order to conduct those meetings, we also need to be able to select and curate the content to be reviewed or discussed during the meetings. Bringing us to the last point of being able to share the content and collaborating effectively and iterative on the design objects and assets. Move on, next one. So we've developed this really elaborate and detailed mirror board that illustrated a kind of step-by-step actions that we need to take in order to fulfill certain tasks. So as we mentioned before, for example, what would be the project initialization tasks and how would the user engage with the system? So basically, which actions would have to be performed? What tools do we need to perform those actions? As well as what functionalities need to be implemented in order for us to be able to establish that kind of example workflow for the platform. So also moving from the kind of initial initialization of the project, how could we collaborate within each discipline, having their internal meetings and also production time for individuals where individual professionals complete their tasks, then meeting and reviewing the results, and then as well as communicating with other disciplines or clients. So that provided us with a kind of holistic view and a map and a brief for the technical developments of those functionalities. Next. As we were also aware of kind of from the experiential point of view that it was important for us to establish a kind of holistic user journey throughout the platform. So in order to capture all of the sphering and what Edu and Daria were talking about, in order to establish spaces for these interactions to take place. And so starting from the left, when you're starting the application on the computer, then choosing the mode, first, is it a desktop type of a mode or the VR immersive mode, then the users, then establishing a space for users to set their preferences as well, to onboard and create their identity within the platform. And then as it progresses to the right, moving them to the space where they can produce and create content, as well as review the design objects and interact with the data. And then towards the collective spaces where different disciplines could meet. Next. So that led us to the kind of establishing of the fundamental requirements. And coming from this paradigm change of moving into the immersive space. Can we go next? We established the kind of functionalities that we need in order to operate in that new immersive space. So first of them would be the multi-presence onboarding system that we need to be able to bring people onto the platform and manage the interaction inside this multi-presence immersive space. Then tagging, which allows us to create this flexible data management system to track the data and decision making throughout the design process. Then query is important in order to isolate the relevant assets. That it could be anything from organizing a meeting, being able to select the assets to review, as well as having access to the kind of totality of the project information that's in an accessible and interactive way. Then we have the kind of baseline functionalities such as dashboard, admin tools, as well as communication tools in order to enable the interactions. One of the interesting ones we found was also a kind of being able to save the locations within the 3D models in order to be able to visit them and create this kind of spatial hyperlinks within the platform. Next.
So you with us so far? I hope so. So just kind of at this point we talked about functionality. So it's it looks very detailed, but it's very simple. We wanted something immersive to be able to design objects through a UI system that allowed designers to interact and that allowed people to access metadata, right? So then we had a clear idea on how to do that. We had a definition of operational scenarios, okay, that we shared across the different AEC partners, and functional requirements that Aleksandra just went through. But obviously, before going and just show the cool stuff, we had to go through the technical architecture. So let's talk a little bit about that. And to achieve all those functional requirements, it has been necessary to provide more detailed technical briefings around. So, and we focus particularly on 3 critical functions. So the concept of a single and persistent data source shared by all of us, because obviously that was, also related to the golden thread and all of that. And to allow everyone to access this data synchronously and asynchronously. So to allow collaboration as it happens for real. The second core function that we had to develop technically was the tagging, the commenting, and the markup features. Obviously, be able to author this data by different level of users, right? And then the third one is which also in a view of actually allowing it to work across all the principal spheres, was the hardest one, was how to grade permission and access rights, because then it gets to a level of involvement that we require also other parties, but we looked at that quite thoroughly as well. So in terms of current AC framework, we looked at the ontologies, obviously the different schemas, and in our industry the dominant ontology is IFC, by Building Smart Consortium. If you don't know about it, there's a lot of obviously explanation online about this. So viewing the model with associated information and having an ontology that allows us to share across, it was kind of the big kind of part of it. So we looked at how then to the different kind of challenges, having a file-based versus an object-based ontology, a file-based versus a database version control, sort of looking at the existing schemas and a different software that we were going to try to connect. What was the sort of best way to kind of grow the interdependentness of all these ontologies into a working function system, but also most importantly, we looked also at licensing and open source issues, because obviously some things come with a closed environment and some others are open, and we had to kind of make sure that we had an open access to everything else. So next slide, please. So obviously, when looking at data formats, we researched different kind of systems. IFC based, as I said, Speckle, which is an open source sort of system that allowed us to kind of maybe take this further in terms of organizing the ontologies through and getting the interoperability to work, as well as React, which is an AKT proprietary system, and BOM, which is developed by Bureau Happel. So we did, again, quite a lot of research on what was currently available, to be able to, again, sort of understand what was the best approach, either having a complete or a composed object model. Predictability versus the flexibility of object model was key also in kind of allowing, for example, things such as AI to come into play. file-based versus object-based ontologies, which actually draw essentially the collaborativeness of the system. And also the version control played a fundamental part in the research, as to comply with the golden thread rules, we also had to provide that level of accessibility and versioning and trackability of the system. So again, quite a lot of research in the background to come to a solution that would tick all the boxes. And obviously it was quite a complex system at some point where we went through all the different points. Next slide, please. So we got to a stumbling point at some point where how do we do to allow this to progress in the relative space that we had of the 2 years of research, but at the same time we wanted something to build up and continue the discourse. So we sort of decided as a consortium to take Speckle on board and to create this composable object model that would allow us to really onboard all the different types of data that we would share between the AEC partners, that would allow us the version control. Obviously, that would allow us an initial web-based 3D model viewer to kind of obviously operate across the different commits. And the possibility of perhaps leveraging on the web-based API. And interestingly enough, this was also previously a Horizon 2020 sponsored project through InnoChain. So it was very beneficial to kind of adopt this, in the research as well, to kind of unlock some of the technical issues that we were experiencing. Next slide, please. But obviously Speckle was not the answer. It was just a fundamental part of the puzzle, but there were certain critical functionalities that we wanted to develop in PrismArch that were not available in the industry. So we sort of needed to extend some of the schemas and that was quite good because Speckle allowed us to do that. And to kind of expand the composable approach that Speckle allowed us. So the signature, identity, and access management was one of them, and that was fundamental to allow sphering level access and rights, which was kind of the base of our proposal. And also different discipline-oriented schemas, such as architectural requirements or structural requirements were not, or MEP requirements, as a matter of fact. And basically, all of the schema, or many of the schema provided we provided both as textual or a C# code, typically a sort of OOP system that allowed us to organize software design around data or object rather than functionalities. So all of these things were. Sorry, Paul, I think your microphone is on. Thank you. Next slide, please. So as you can see here, the different schemas definition from the entities, broke them down exactly on what we wanted to sort of assign on the schemas, and then we managed to sort of make them compatible to Speckle, basically. So you can see a couple of examples here. Next slide. Obviously important was also to look at the server architecture for the reasons I mentioned before, but also to make sure that items such as data integrity and data sovereignty were kind of implemented and sort of crucial to the design. So on that side, we also analyzed for potential different solutions to be able to achieve the necessary sphering level, and each and every one of them has a different data security, attached to it. So, but the core solution had to support the existing Speckle data transfer mechanism, and obviously allow us to modify the authentication for the existing software and the data exchange mechanism allowed in the system. Next slide, please. Technically, also the core requirement for the VR sort of were described in user scenarios, diagrams, and detailed in the different interactions between different core PrismArch users. So just between some of them, the onboarding, as Daria was mentioning before, UI interface within your personal sphere, the immersed interaction with the design object, a meeting sphere design, which that was actually quite interesting, like how to design a place where people could interface within the same sphere. The interface for element query. You know, when an element's got so many tags and association attached to how we looked at how we navigate through all of these data and what is the best way to then get to the point of selecting what you require as a designer. And also archiving and retrieving different design solution. You know, that was also part of the study. Next. And lastly, also, we've been developing discipline-specific requirements for PrismArch. Every different discipline had a different requirement to onboard. So we analyzed the existing VR precedents, and we made general proposal to bring across some fundamental requirements, such as visualizing sectional properties of elements, or assessing, you know, stresses or dimensions or performance, you know, quality of specific elements. And we did that for each and every different discipline: architecture, structural, and MEP. So next.
So to summarize all of these, all of the research and the kind of functionalities we've been identifying along. If we can go to the next slide. We've identified the kind of at the core of interaction is this unified database, and the data interoperability is a very important point for us in order to, so that we can speak the same language in the platform. So models coming from various softwares can be viewed in the coordinated location, and then those at the data, and the data sets are demarcated. So for example, if the structural engineer produces a model, then we can clearly identify it within the master model, that's this architectural envelope. And then we're also able to retrieve the information of the ownership and therefore having that kind of management of IP within the project and the data sets within the platform. So next. And so at the back end of this, we identified the need for having the information management system. That's the kind of that is interactable, and that it's it contains the total of the project information that is uploaded on the platform or created within the platform. And then from the kind of experiential and human perspective, we need to be able to visually identify and distinguish these core elements as identified in the slides before. So we need to be able to know which object represents the metadata, which one is the design objects, what are the assets that we're interacting with, and then having UI to be able to interact, as well as communicate with other humans in the space. In the project data, we were also at the user level, we need to be able to have flexibility to assign the access rights, edit rights, and be able to identify who can view and how to share the data produced by the team. Can we go next? Therefore, in a front end perspective, we identified the kind of parts that are discipline agnostic, like interdisciplinary, which is the interdisciplinary domain, which includes the sphere functionality that regulates the communication within the parties, then the administration part, as well as customization and modifications. And then on the other hand, we also recognize the in-discipline specific domain, which could be any consultant joining the project. They might have their specific requirements and workflows and the way they and requirements for the platform to accommodate those their workflow. As an apologies. We also identified the universal functionalities such as the environment, which basically contains all of these interactions and can enable them, as well as the avatar functionality, so that we can recognize and recognize different parties, as well identify ourselves within the collective, and be able to communicate. Next slide. So in the next slides, you will see our proposals and how we envisage the kind of virtual environment, which is purposely built to accommodate the unique functions that we outline that as a requirement for the PrismArch. Then also the UI elements for the multidisciplinary interface. We've established also the avatar creation and customization interfaces, and all of the functionalities that we've discussed previously, the sphere. So in the next slides, you will be able to see more how we imagine all of these requirements come together into the user experience mockups. Next.
If we could start from the next slide, please. So the core interest of PrismArch was to develop a unified platform and to offer a coherent multi-presence user experience, as we've been discussing so far in terms of user interface. So this diagram, which Ola has already explained a bit, but this is a sketch of a kind of overall experience and use sequence and the journey from starting the application through to exit. But through this exercise, the MVP were discussed between all partners to finalize a list of functionalities and technical roadmap. And briefly explaining this, part A, showing, let's say, user cognitive shift between physical reality and virtual reality. This was important to consider because users need to switch from desktop mode, VM modes. And then part B, showing the customization aspect, including login details, avatar selection, workspace, graphic setup, etc. And part C onwards is kind of the situation after user loaded to the virtual environment. And then users have options to select single production mode or create a meeting to go for multiplayer review mode. So these kind of shift and switch from single to multi-presence modes should actually be visually noticeable for users to have, let's say, comfortable and consistent experience. So this was done by having a unified and persistent user interface for all disciplines. And also we introduced this idea of flexible and dynamic workspace envelope for designer sets as well as the loaded users inside the worksphere. We will go through this in the next couple of slides. Next, please. Okay. So this diagram illustrates the interaction categories or layers relating to digital human body. So the one being closest to the primary, to the avatar body is the primary gesture based, and the secondary is more like a manual operation done by users. And then the external one is the dynamic interaction with the environment that has kind of real-time adaptability and flexibility to the environment that the user are being inside. Next, please. So to highlight that functionalities tied into the UI is all interconnected and there are interrelations. So any disconnection of these items would actually cause disconnection of the user experience itself. So what we needed to do is to have an overall picture of the whole UI. So this shows the layout of that and breakdown of functionalities and user interface using the PrismArch following the 3 categories we mentioned in the previous slide. Next, please. Next, please. Yeah, so showing an initial and potential idea of gesture-based UI operation to have more intuitive user experience for production mode. The gesture-based operation would actually break the mental disconnection between the digital human asset and the user interface asset. Next, please. And in order to simplify the user operation process we just talked about, we kind of proposed to have a minimal smartwatch-like UI with only 4 buttons. So each represents, let's say, fundamental elements of PrismArch. 1 is digital human / avatar. 2 is the design objects that the user actually create inside the virtual reality environment. And 3rd is some functionalities and also APIs or any kind of plugins. And the last one is the metadata graph, which is equivalent to 3D file explorer access. Next, please. Yeah, additional preview monitor was introduced to speed up users' production workflow. And operation of preview monitor UI is also not just limited to view projected content, but also can be used as a presentation monitor and also works as like a secondary monitor to focus on the actual production actions. Next, please. User scenario to interact with design objects. So we had to kind of think about the vertical adjustments to review the models from both kind of eye height and also the bird's eye point of view. And we also proposed some ability to crop models to work on a specific part of the buildings. So scaling and also the, let's say, focusing point design scope is something that we also considered within the kind of suggested production work pipeline for the industries. Next, please. Next, please. Next, please.
So for the operation of the design objects within the space, we wanted to create a tool that would allow users to interact with the objects. And in order to simplify the amount of different interfaces and ways of interaction, we propose one tool that could adapt into a variety of conditions. Therefore, we developed a multi-tool, which, as you can see here, we identified the multiple scenarios. One of them could be operating a model at scale model that is in front of the user on the right top image. Another one is that poses its own sets of challenge would be to operate the model at 1-to-1 scale, where the building scale is much larger than the user. Therefore, we propose a kind of remote version of the tool that would allow you to operate on that larger object from the distance. then we could also imagine that we could use the same tool to operate the metagraph, and in order to be able to search through the metadata sphere, which you can see on the third image from the top. Then potentially we could adjust environments and other parameters of the space, such as size of a clipping plane or other custom parameters such as daylight or discipline-specific aspects. Next. So here you can see the form of the multi-tool that is in the production mode, where the user wants to perform certain transform operation on the object on a selected object. Therefore, we identified a certain elements that we think would make the interaction user-friendly. So we have those. We have the UI guides that you could use to adjust the model, to adjust the tool to operate within certain axes. We identified pivot point, which we might want to change depending on how we would like to adjust the model and from what point. And then we have the form of the multi-tool that has a corresponding functionality to adjust, for example, the translation and scaling or rotation. So depending, if we could go to the next one. So as you can see here, if you interact with the different parts of the tool, they become enlarged and they allow you to adjust those parameters. Next. I think this is more visible. So in a way, you could select the object, select the functionality that the parameter you would like to adjust, and then the tool shape of the tool responds to your to you interacting with it, enabling you to perform the operations you want to perform. So the idea was to make it very intuitive, and after a certain amount of training, the users would be able to easily interact with the objects in the virtual space. Next. So we also envisage a kind of presentation mode, which we identified as its own scenario, where we see it as a space where we have a curated content, where we don't do as much as ad hoc adjustments, but we can kind of preset a certain scales or certain operations and changes to the model, and then revisit them during the meeting. Could we go next? You can see it here. So this little tab is a minimized form of the tool that, when interacted with, expands to the kind of preset set of tabs and functionalities, which you can then select and then operate the tool in order to make your modifications. Next, please. Here you can see the enlarged view of the 1-to-1 scale scenario, where you are in immersive space and you stand in front of the building, and you would want to modify the building in front of you. Therefore, you can see that we have the kind of visual cues for the user to see that ring around the selected object, and then in front of the user is the multi-tool at its in a comfortable and ergonomic size for the user to be able to interact with. Next. So throughout this process, we developed a lot of we've detailed a lot of actions that users would have to take on in the virtual space. If you can go next. So here we will show you a kind of snippet of all of the storyboards and kind of our workflow of how we broke down each activity into individual moves and interactions for the users to be able to complete their tasks in virtual space. So those were used as a kind of step-by-step instructions to brief the technical development. So you can see various interfaces being detailed in such way that that you can step by step see what is the user interaction and how is system responding to those actions.
Okay, so in the last 9 slides or so, showed that the UI was kind of user-centered and manually operated examples. Next, please. So along with the development of multi-tool, it was kind of necessary for us to consider the relationship between users and scaled design assets. So our questions were, what happens if users load the urban scale master plan model from the 3D metadata graph? And what if this was a product design model? Because there is a huge gap and different types of projects, and it is not rare, especially for architects and designers, to work on, let's say, multi-scaled or multi-types of projects. And the idea of dynamic environment UI here is to kind of flexibly envelope all the 4 fundamental elements we had been discussing throughout the presentation, which is the digital human, as in users, and then design objects, PrismArch functionalities, and all the UI tied to that, and then the 3D metadata graph. Next, please. So we also questioned the actual capacity and size of production space when users are in single player mode or multi-presence meeting mode. Obviously, you would need much bigger meeting room if you invite 10 people, but if you want to focus on a model on your own, the space might be much smaller than that. Next, please. So another question to ask was how the envelope transforms and changes its scale, and how users can recognize again the shift of, let's say, different work modes, whether it's a production versus a review or single versus multiplayer. And we thought there are 2 ways of transforming the worksphere envelope. In both scenarios, all UIs and avatars still persistent and consistent. But the first is the, let's say, user manually adjust the worksphere size by setting minimum and maximum value. And the second is the system itself automatically calculates and adapts the content size, and users confirmed to transform the setup so that the users actually see the procedure and transformation process in an animated form. Next, please. Yeah, so this kind of shows the final visual mockup and overall sequence and user experience from, let's say, login to remodeling, production mode, etc. So when you log in, you see the PrismArch logo. So is it animating? Oh yeah. So this is the production mode, and then the envelope dynamically changing its scale, and then enlarge the room so that more people can join in. You can go to 1-to-1 mode, and then yeah, again, you can come back in to log in to start production mode again. So we were kind of interested in this kind of very continuous and coherent overall experience, and then PrismArch application can be seen as one continued experience. Next, please. So the next 1, 2, 3, 4 slides are some of the visuals that we did in earlier stage, and this is a clipping plane tool. Next, please. Yeah, again, the idea of, and inside the production mode, you will be able to have different design options and compare the ideas, and inviting, let's say, colleagues to have a review and meetings inside it. Next, please. Next, please. And I think Daria will be wrapping up the presentation by going through the documentation aspects and deliverables and stuff. Thanks.
Yeah, so what everyone has shared summarizes or sums up our vision for the PrismArch platform, which decidedly is more than 2 years of development. We've been working towards an MVP with our consortium partners, but the vision exceeds the capacity of a 2-year development project, so we will hope to take this forward. In the meantime, you can see our documentation in the deliverables that are published online. Deliverable 1.1 talks about the functional requirements and the first, let's say, investigations into our current multidisciplinary situation, and how we currently try to solve these problems with our existing workflows. Deliverable 1.2 talks about the technical architecture as also presented by Edo. And here you can go into much more detail about the various classes and the proposals for using Speckle as the interoperability solution. A Spearing white paper was published where the concept of consolidating IP and registering the environment to tell you who is responsible and who has access to any given, let's say, consolidated group of information. This is a theoretical proposal that was put forth as a result of the research. And deliverable 1.3 is a summary of the operational requirements. And again, just an overview looking back together with all of the more recent mock-ups and UX development as was presented by Ola and Risa. So thank you very much for your attention. And although we are just over an hour, if you have any questions, please feel free to ask them and we'll do our best. Or if you have any feedback as well, we would love to hear. All right, well, thank you very much for your presence here. And we hope to see you another time as we present this is the end of our, let's say, four webinars for PrismArch at this stage, but we do hope to be taking this project further and hope to be sharing more with you in the future. Thank you very much.
Thank you.
Thank you.